Starting off with Section 1, the reliable classics. Here, it's all about simplicity, control, and durability.
Okay, first up, we have the undisputed king worldwide, the pump-action shotgun. The core engineering philosophy here is incredibly straightforward. Fewer moving parts simply means fewer things can go wrong out in the wild. This design actually dates all the way back to the 1882 Spencer, and it absolutely prioritizes control over raw speed. You use that sliding forend to eject and load shells directly from the tube magazine. Because it doesn't rely on complex gas systems, it is incredibly reliable in dirt, heavy rain, freezing cold, you name it. Literally, some models from the early 1900s are still functioning perfectly today. Famous ones you might recognize are the Remington 870 and the classic Winchester 1897.
Now, let's look at something even simpler. Break actions and single shots. With these, you literally just break the gun open on a hinge to load the shells directly into the chamber. They have the fewest moving parts of literally any shotgun out there, making them the absolute champions of reliability and low maintenance. The single-shot version, which obviously holds just one shell, is super affordable. We're talking often well under $100, and it's a really fantastic tool for teaching beginners how to aim carefully, since, well, you only get one try. Building directly on that break-action simplicity, we've got the double barrel styles. This gives you a maximum of 2 quick shots before you're forced to reload. And they generally fall into 2 main camps. First, side by side, where the barrels sit right next to each other horizontally. And second, over-under, where one barrel is stacked neatly on top of the other. These are famous for having excellent balance, but man, the over-under models can get wildly expensive. A Krieghoff K80, for example, that can easily set you back over $10,000 for a single gun. No way! Rounding out our reliable classics, we have bolt-action shotguns. Much like a bolt-action rifle, you manually lift and pull a bolt backward to eject the spent shell, then push it back forward to load the next one. But instead of a traditional tube, these actually often use a detachable box or an internal magazine. They're incredibly simple, very durable, and they were super popular in the late 1800s and early 1900s for farm defense and hunting, right up until pump actions really took over and basically stole their jobs.
Alright, moving out to Section 2, the need for speed. It's time to look at firepower versus pickiness.
This brings us to semi-auto systems. With these, there's absolutely no pumping required. The gun automatically loads the next shell after every single shot. But here is the crucial trade-off. To get that rapid speed, semi-autos are incredibly picky. If you feed them cheap shells or let them get dirty, they will absolutely quit on you. Engineers achieve this firing speed in 2 main ways. You've got inertia-driven systems, which cleverly use the gun's own physical recoil to load the next round. They're lighter, but they deliver a pretty harsh kick. On the flip side, you have gas-operated systems, which siphon off gas from the fired shell to cycle the action. These offer a much softer recoil, but they demand a whole lot more cleaning and maintenance to keep running smoothly.
Before semi-autos took the crown for speed, we had lever-action shotguns, like the iconic 1887 Winchester. To cycle the shells, you basically flip a large metal lever down and back up. Now, while they were eventually replaced by faster, more modern designs, they were completely immortalized by cowboy movies and, let's be honest, Arnold Schwarzenegger and Terminator 2. The main engineering drawback here, though, was that big lever swing required a lot of physical space, which made them pretty tough to maneuver if you were caught in tight quarters. Taking speed to the absolute extreme, we arrive at fully automatic shotguns. This is pure destruction. Unlike semi-autos, these just keep firing continuously as long as you hold the trigger down. Standard tubes simply couldn't hold enough ammo for that kind of ridiculous output, so engineers had to shift to huge box or drum magazines just to keep up. As a result, these weapons are massively heavy, often weighing 10 pounds or more empty, and are pretty much exclusively military or experimental weapons like the famous AA-12. To really put that sheer power into perspective, 300 rounds per minute. Just let that sink in for a second. You could empty a massive drum magazine in the blink of an eye. However, the engineering trade-off is brutal. The continuous heavy recoil means your accuracy just drops off a cliff, making them somewhat effective up close, but practically impossible to control over any real distance.
Let's jump into Section 3, historical and weird designs. This is where we look at the experiments, the cannons, and the cylinders.
First up, we have to talk about muzzle loaders. These were the original shotguns, used from the 17th straight through to the 19th centuries. Think of what pirates carried. You had to load everything from the front: powder, wad, shot, wad. It was an agonizingly slow process, maybe yielding 1 to 3 shots a minute if you were really fast. But the scariest part? The hang fire. If you messed up a step, you'd pull the trigger, nothing would happen. And then, seconds later, boom.
a highly dangerous, totally unpredictable delay.
Now for something completely ridiculous, punt guns. These were engineered for one very specific purpose: mass commercial hunting. These shotguns were so absurdly massive they literally had to be mounted on small boats, which were called punts. The hunter would just aim the entire boat at a flock of birds, and a single shot could take out 20 to 50 birds all at once. The recoil was so intense it would forcefully push the whole boat backwards through the water. Unsurprisingly, they were so destructive to wildlife populations that they were eventually banned globally for conservation reasons.
To put that sheer crazy scale into perspective, some of these things were 10 feet long. That's practically the length of a small car. Some of these boat-mounted cannons weighed nearly 100 pounds and fired custom shells that were 2 inches wide. They remain the absolute largest shotguns ever built, though today they're mostly just gathering dust in museums or sitting in private collections.
Another historical oddity we absolutely have to mention is the revolver shotgun. Imagine a giant revolver mechanism, but scaled up for shotgun shells. Instead of a standard tube, it features a heavy, bulky, rotating cylinder that holds up to 12 rounds. Famous models include the Street Sweeper, but the trade-off here was incredibly steep. Designers basically traded practical weight and simplicity for massive bulk, mechanical complexity, and a 12-round wow factor. It's a neat concept, but they just never caught on for practical, everyday use.
Finally, let's explore Section 4, Modern Tactical Innovations. This is all about adaptability and close quarters.
Modern tactical models completely strip away those classic wooden hunting aesthetics for pure, unapologetic function. If you see a shotgun used by law enforcement or for home defense today, it definitely has these upgrades. We're talking shorter, 14 to 20-inch barrels, specifically designed for moving easily through tight spaces like hallways and vehicles. They boast higher capacities, holding up to 9 or more shells. They are decked out with tactical rails, flashlights, and adjustable stocks. And instead of your standard birdshot, they're loaded with heavy buckshot, solid slugs, or even specialized breaching rounds designed to literally blow the hinges off doors.
Then we have an absolutely brilliant engineering solution, the hybrid shotgun. This is really the best of both worlds. You start by firing in a rapid semi-auto mode, but say you encounter heavy dirt or you're using weak ammo and the semi-auto gas system jams up, no problem at all. You just flip a selector switch and you manually cycle the gun in pump action mode so you can keep firing. Models like the SPAS-12 offer this ultimate fallback. You're trading extra weight and complexity for supreme reliability when everything else goes completely wrong.
Now, what happens when you aggressively modify an existing design? You get the sawed-off shotgun. By literally taking a hacksaw and chopping the barrel down, the gun becomes incredibly maneuverable and very easily concealed. Some people literally just slide them into their pockets like handguns. But here is the massive fundamental trade-off. Chopping the barrel absolutely destroys the muzzle velocity and the weapon's effective range. Because of this, they are strictly regulated. For instance, US federal law requires a minimum 18-inch barrel for civilians, precisely because these guns sacrifice their range entirely just to become concealable.
So how do modern engineers solve this length problem without losing all that crucial range? Enter the Bullpup. This design is basically a masterclass in modern problem solving. A bullpup configuration actually takes the action and the magazine and places them behind the trigger. This allows you to keep the full barrel length, maintaining your high velocity, but it packages the entire system into a highly compact, maneuverable size. The only real drawback? Well, placing the ejection port right next to your face can be a bit dangerous, especially if you happen to be a left-handed shooter.
All right, let's bring it all together and summarize the core trade-offs among the big 3 designs. If you need incredible reliability out in the mud and rain, you choose the pump action, but you sacrifice fire rate. If you want high-speed firing, you choose the semi-auto, but you accept that it's going to be picky with ammo and require a lot more maintenance. And if you want the absolute simplest tool on earth to maintain, you go with the break action, but you have to accept you're limited to holding just 1 or 2 shells at a time.
Given all these centuries of engineering trade-offs, of constantly giving up one advantage just to gain another, it really leaves us wondering, as materials get lighter and hybrid systems get even smarter, what will the ultimate balance of speed and reliability actually look like in the next evolution of the shotgun? What incredible engineering breakthrough is waiting just around the corner? Thanks for joining me on this explainer. I really hope this helped you structure your understanding of this fascinating mechanical evolution, and I'll catch you on the next one.